Are we good? Everybody drawing their little pictures? All right. Are we ready for the next one? Yeah. What's the next one going to be? What will it be? Will it be? Will it be both ends free? So for both ends free, it's sort of tricky because you don't have little dots you can draw. So some people like to draw like a pipe that they're going to fit the waveform in, right? I want to draw a narrower pipe though, right? But make the pipes the same length. If your pipes are progressively getting longer, that's sort of the sign that you're kind of a beginner, which you are, but you know, that's okay, right? So this guy's got a node in the middle. This guy's got a node a quarter of the way, a quarter of the way. This one's got one in the middle, a sixth of the way, a sixth of the way. Yeah. And these are the first three modes, and if you can draw the first three modes, yeah, that's right, then you can draw the seventh mode, right? Or you can generalize. Try to make them the same length. Very good. Bien fait, monsieur. Yeah, that's right. Make the ends antinodes. That's right. Ooh, look at that. That's pretty. Yeah, look at you. Yeah. Yeah, she draws the shapely waveform. I'd have to agree with her, you know. Notice the other one. The other one's a little shorter, that first one. Hers are like more or less the same length. It's very esoteric, you know, it's like judging ice dancing. You know, do you land with your heel pointed out or is it pointed straight behind you? There's a tenth of a point right there. You know? Bellissimo. Fantastico. Bellissimo. Fantastico. I can just say that. Bellissimo. I love that animation. It's like whoa, whoa. Or it should just like start disappearing in parts, right? You know?
You only get it for 5 seconds.
Like Star Trek. That's right. Star Trek on a bad day, right? They start to appear and then they like. Is that what the rapture is going to be like? Are people going to disappear like on Star Trek, where they kind of like?
Beam me up, Scott. What's the rapture? It's when God chooses who goes to hell and goes to heaven. I marked it on my calendar.
Good Christians won't drive on Saturday because, think about that. Your car keeps going, right? Yeah. Oops. So for this guy. Shh. You can draw a little pipe like this that's closed on one end, right? See if you can draw that guy. Remember, this guy has just one node and it's there. This guy's got a node a third of the way down. It's the Jesus fish. Right? And then this guy's got a node a fifth of the way down, 3/5 of the way down. Release the balloons. That's right. That'd be a little bit hostile to drop a bomb in the middle of the crowd. You know? They've already forecast for classes, though, haven't they?
Yeah.
I'm just kidding.
Are they 8th grade?
That's right. No. I think it was like 10th graders, I'm guessing. Yes. Oh, very nice.
Yeah, I remember 8th grade. Freshman year's the only time I saw 8th grade. Oh, I get it.
Fantastico. Bellissimo. Still hers.
Yeah, mine's always been.
Still hers, I think.
This
That's
mic
right.
is dead.
Yeah.
You can be good at everything else.
That one? What is it? Where's it from?
It was from the refill.
From the what?
It was from that box.
Oh, that box. That's sad. I'll refill it again. Here you go. One end needs to be an antinode always. Are we good so far? That's like your. Oh, I see. Yeah. You got it. All right. So now it comes down to it. Shut up. Okay. Let me show you how it is that you can calculate. If you know that, for example, this thing here is 70 centimeters long, then how long is the wave? Okay. Concept 0 is that the wave is 2 full footballs. Looks like this. That is a whole wave, right? The most common student mistake is that they think 1 football is a whole wave. No, 2 footballs is a whole wave, right? So concept 0 is that this is a whole wave. And that's because, of course, it looks like this now, but it's going to look like this a little bit later. The whole wave always was 2 humps, right? So this is 1 wavelength, right? And then, of course, you can break a 1 wavelength down into 1/2 a wavelength. But the smallest thing it's ever broken down into is a 1/4 wavelength. So that's what I'm going to show you, right? Is it really the smallest unit of currency is a 1/4 wavelength. So a 1/4 wavelength looks like a little wine glass or a water goblet or something like that, okay? That's a 1/4 wavelength. So there are 4 1/4 wavelengths. That's a whole wavelength, right? Okay. So let's look at these guys, and let's just say out loud how many 1/4 wavelengths there are. 2 1/4 wavelengths. Yes. There are 2 wine glasses, one on the left, one on the right. They're facing each other, something like that, right? Right. How about here? How many quarters? 4. Yeah, there's 4 quarters, right? 1, 2, 3, 4. 3 quarters, yeah. 1, 2, 3.
5, 6.
Fuck, 6. Alan! There you go. Yeah. 1, 2, 3, 4, 5, 6. If it's symmetrical, by the way, if it's got bilateral symmetry, it's got to be an even number of quarters, right? All right. So, yeah, there's 3. There we go. This is good. Okay. So now, let me just show you how you set these up if you want to calculate the wavelength. Okay. What you have to do is you have to use 8th grade algebra. Okay. You have to set up. No, actually 7th grade algebra, I believe. Okay. You have to set up. No, it's 8th grade. It's 8th grade. You have to set up a number sentence. So in this case, this example is the Jesus fish, right? Right? This thing is, the first thing is that you realize that this length here, okay, this length is 8.45 meters, that this thing is, right? The 8.45 is equal to 3 1/4 wavelengths, isn't it? And that's how you say it mathematically, and that's how